We're exploring enhancing strawberry pollination by using drones to circle the air as well as collecting yield data. The UK strawberry sector relies a lot on nature and human interaction with monitoring the yield.
In these controlled environments which have allowed us to grow food throughout the year, you need bees to also be doing their job during the winters as well.
If it's too cold, or likewise if it's too hot, the bumblebees will not come out of their hives. Therefore, this can lead to some mispollination, which can lead to some berries not being correctly formed.
A lot of the processes are subjective. So for example, when it comes to picking the fruit or making a forecast, that's where our technology can come in. What we're trying to bring in is the use of drones as essentially a scout, counting the fruits in your glasshouse to give you the forecast for your next week. We decided to deploy in two different sites, mainly Barnsmore in Scotland, which is polytunnels, and Soft Fruits in Somerset, which is mainly glasshouses.
So this project is funded by Innovate UK and Singapore Enterprise, with the lead partners of Angus Soft Fruits as the growers, Singapore-based Polybee as drone technology specialists, and UK Agri-Tech Centre as project management and technical support.
So at the core of the system is Polybee's own technology called Navebee.
We're using an off-the-shelf DJI Dock 2 and a Matrix 3.
The drones will come up, they will fly through the tunnels, and at the same time as pollinating, they will capture images of each individual berry, flower, set fruit.
The downdraft of the propellers allows for the pollen to be blown gently round about the crop, allowing it to be pollinated in a similar way to what a pollinating bug will do.
Along with the pollination, we were also collecting data. So as the drone would fly for daily flights for pollination, it would also be clicking images of the plants to essentially track the growth of each individual fruit.
So once the drone has gone back and docked, it uploads the data automatically.
The data that we collect through these drones can then go through some state-of-the-art AI models that we're working with to essentially count every single fruit in the farm and produce an accurate yield forecast, leading to the uncertainty essentially being eliminated from the whole process.
That then helps with the crop growth and yields, a longer season, which can then help reduce imports.
The AI can pick out different colour shades within the berries, and this is important for our different ranges that we have in our retailers. It enables our growers to forecast their labour profiles. So we're testing the fruit in 2 tunnels here against 2 tunnels non-treated with the drones.
We're hoping to see an increase in value of the strawberry crops of up to £8,000 per hectare in forced heated systems.
There's human scouting being done on a weekly basis to compare the drone pollinated tunnel alongside the control tunnel.
We're looking to see improvements in yield of Class 1 by 20%, a 10% increase in the premium sales, but also a 30% higher net return per kilogram than C1. The biggest thing is we will reduce waste. We're validating this work by monitoring the environmental factors inside the tunnel. So every 15 minutes, the devices are tracking temperature and humidity, both inside the polytunnel and external, so we can compare the temperatures. Putting the data onto this website is allowing us to validate if the drones are required to fly when they are flying.
Since picking has started to happen at this farm, we've been able to get some numbers, and the tunnels where we were using drones for pollination, on an average for Class 1 and Class 2, we're seeing about 2 to 5% yield improvements, which is massive.
From the results that we've gotten so far, it's looking promising and looks like it's going to be a big success.
So we, as a project consortium, are looking for other links and opportunities for other fruits in the sector.
Now that we're more confident in our operations and in the safety that comes with the autonomous drones operations, we plan to deploy our next set of trials completely autonomously, where we wouldn't have any human intervention or a manual operator nearby.
So the final result of the project should be a repeatable, scalable solution that supports data-driven harvest planning. So for more information on this project and others we are taking part in, visit our website.